Okay, in this video we're going to talk about some arc measures, angle measures, and later on some arc lengths. So let's just talk a little bit about angles and arcs again, right? So if I have a central angle here, it subtends this arc, right? And again, we can talk about this. So again, just to practice some vocabulary, angle COT subtends arc CD, right? Let's erase that. Okay, sorry. And in terms of angle measures, whatever the measure of this angle is, say it's 30 degrees, the arc has the same measure. So the measure of an angle is equal to the measure of the arc. Okay, both angles and arcs can be measured in degrees or in radians. Okay, and radians are going to become important as you move through mathematics. Okay, so degrees or radians. Which means if you had an arc that went all the way around a circle, right, that's 360 degrees or 2 pi, right? If I drew a diameter here, right, this arc here is 180 degrees. Okay, so arc and angle measures are the same when the angle is central. Okay, so the key to this whole thing is if this is a central angle. Okay, so again, if I drew this, if I know this is, say, 20 degrees, right, then I know that arc ED is 20 degrees. Okay, now what we're going to talk about is inscribed angles. Okay, so if I have an inscribed angle, right, this angle, this arc, I'm sorry, AB, right, what's the measure of that arc? Let's say for right now that this angle is 20 degrees. Okay, so what we know, so if we start thinking about this, is that, right, so what we can say right now, we'll call that circle O. So we know that the measure of AB, the arc, is equal to the measure of angle AOB, right? Problem is we don't know how big AOB is. So let's look at that for a second. Okay, so how we're going to figure this out? I'm going to explain this, and then I'll give you the rule. In order to explain this, I just need a little space. So we're going to erase this for right now. And what I'm going to do is I'm going to create out of here two triangles. Okay, so now I have triangle AOC and I have triangle BOC. Something I want you to notice about these is these are both isosceles triangles, right? They're not necessarily congruent because what we do not know is that CO bisects angle AOB. We do not know that, okay? What I'm going to do is I'm going to extend this green line to make a diameter, okay? So I know that this is an exterior angle to AOC. It's exterior, which means that it is equal to the sum of the two remote interior angles. So for right now, I'm going to call this X and this X, that whatever X degrees, which makes this 2X. Similarly, in the other triangle, I'm going to make this Y and this Y, so this is 2Y. Right? So what this tells us is that the measure of angle AB, arc AB is equal to 2X plus 2Y degrees. We know now that the measure of angle ACB is equal to X plus Y degrees. Right? So if we look at the relationship between these two, in the end what we can say is that the measure of arc AB is equal to half the measure of angle ACB. So in general, an inscribed angle is half, I'm sorry, I did that backwards, sorry. This should be double, right? So the arc is twice as big as the angle, right? So if we erase all this and we go back to our original problem and we say, hey, if this is 20 degrees, then this arc is 40 degrees. Okay? Hope that makes sense. Finally, now we're going to talk about arc length. Okay? Finally, now we're going to talk about arc length. So arc measure is measured in degrees and radians. Arc length, however, is the actual distance you're walking when you walk there. So this is a linear distance, so meters, feet, centimeters, something like that. Okay? So if I knew, say this was 35 degrees, I want to know how far is this? Okay? Not the measure of it, but the length. In order to do this, I'm going to also need to know the radius. Okay, and the reason I'm just going to make this up right now. The reason I want to know the radius is I need to know the whole circumference. So remember, circumference is equal to 2 pi r. Okay, so this whole circumference of this circle is going to be 12 pi. Right, that's our circumference. Right, and we want to know just a portion of it. Right, we want to know this proportion. Right, that's going to be the same proportion of the circle as the degrees. Right? The same section. So in a whole circle, there's 360 degrees. In our case, we just want 35 degrees. So if we cross multiply here to solve this equation, we have 360x, right? We cross multiply, is equal to 420 pi, right? So I solve for x. So x is equal to 420 pi divided by 360, right? 420 pi divided by 360, which if you want to put that in decimal form, is about 3.66, or you could reduce your fraction and make it, or if you just did this in reduced fraction form, this would be 7 pi over 6. Okay, so just to recap, right, what we did is we set up a proportion where we had, in fact, I'm going to write out the words here for this proportion. Okay, so the words were the arc length over the circumference is equal to the central angle over 360 degrees, or if we did this in radians, 2 pi. Notice, right, with this could be our variable like in our example, or this could be our example. If we knew our arc length, we could figure out the central angle.